right. 6.8, confidence intervals and margins of error. So one of the primary jobs of a statistician is to estimate characteristics of populations, called parameters. For example, what proportion of students drive to school? What's the average weight of a teenager? To make these estimates, statisticians will select a sample from the population of interest and study the members of the sample. However, because of variability, it's important that these estimates are constructed in such a way that also conveys information about the anticipated precision of the estimate. So, if you want to predict something, you want to say, I am this confident. I can predict within this level of certainty that this is the case. In general, there are two types of estimates: point estimates and interval estimates. So, a point estimate is a single value. Sorry, my marker was off. A single value estimate for a population parameter. Most unbiased point estimate of population mean is the sample mean. That's the best. So, market research has used the number of sentences per advertisement as a measure of readability. They took a sample, random sample, of the number of sentences from 50 advertisements. Find a point estimate, also known as the average, for the population mean. So, if you take all these numbers, put them into your calculator, run your stats, you'll see that n is 50, we know that. And our point estimate, or our mean, our average, is 12.4. However, the probability that the population mean is exactly 12.4 is virtually zero. So instead of estimating the mean, the population mean, to be exactly 12.4 using a point estimate, you can estimate that the mean lies in an interval. This is called making an interval estimate. So you hear this a lot of times when you hear about popularity of a politician or the polls going into the election. And they'll say, 75% of the people, give or take, or within 2%, are voting for this person. So 75% is the average, but give or take 2% means you're talking about between 73 and 77. That's an interval. So an interval is also a range of values used to estimate a population parameter. Now, to form an interval estimate, use the point estimate as the center, or the start, the mean of the interval, and then add and subtract the margin of error. So, using an interval estimate greatly increases the probability we're correct. For example, I predict the high temperature tomorrow will be between 0 and 150 degrees. But there's a trade-off between confidence and usefulness. This interval will help me pick my clothes in the morning. It's too large. Okay? Now, the probability of the interval estimate contains the population parameter. C is the area under the standard normal curve between the critical values. If the level of confidence is 90%, that means we're 90% sure that the interval contains the mean. Okay? So we can go 90%, 95%, 99%, and these are the Z-scores for those confidence. Okay, so for a 90% level of confidence, we use a Z-score of 1.65, 95%, 1.96, and 99%, 2.58. What I'd like to talk about is, think about a dartboard. Okay? So, I may say that I am 90% sure of hitting the center here. But I have a 95% chance, I believe, of hitting the center or this first ring. And I'm pretty darn sure, 99%, I can hit the dartboard, just anywhere on the dartboard. Okay? So as my level of confidence increases, look what's happening to my z-score. They're getting bigger and bigger. So my margin of error is going to increase. So sampling error is the difference between the point estimate, remember our mean, and the actual population parameter value. So the margin of error is the greatest possible distance between the point estimate and the value the parameter is estimating for a given level of confidence. So margin of error is the capital E. Here's our z-score. Okay, right here. This, again, is our standard deviation, and here's our sample size. Now, what could you do to minimize the error? Increase N. Increase your sample size. So, how do we construct an actual confidence interval? It's very simple. Here's your point estimate, your mean. You do plus or minus the z-score. That's going to be one of those three, 1.65, 1.96, or 2.58, times the standard deviation divided by the square root of our sample size. All right? And remember, we want to have at least 30 in our population to be normal. So let's see how easy this is. College admissions officer, director, wishes to estimate the mean age of all students currently enrolled. And a sample of 40, that's my N. The mean was 22.9. From the past studies, the standard deviation is known to be 1.5. And the population is normally distributed. That's important to know. Construct a 90% confidence interval. As soon as I see 90%, I'm thinking a z-score of 1.65. And it's good to note that, to remind yourself. So, check my condition. Well, first off, I need to have greater than or equal to 30. My sample size is 40. Check. Find the z-score for the critical value. Like I said, that's going to be 1.65. Find the margin of error. Now, the margin of error, remember, that is just this part right here. Okay? So the margin of error is going to be 1.65 times 1.5, our standard deviation, divided by the square root of 40. That's going to give us 0.39. Okay? That's the margin of error. That's kind of like the standard deviation. That's where we're going to add plus and minus to the point estimate. So the interval estimate is the average plus or minus big E. So it's going to be 22.9 plus or minus 0.39. So my estimate with 90% confidence is 0.29 to 22.51. That's my interval. That's my range. Okay? And I can predict that 90%, with 90% confidence, my actual value will fall within that range. Now, last example. Use the magazine advertisement data from example 1, the first page of your notes. That was the one where we had the 12.4 average and N was 50. So let's just remind ourselves, N was 50 and X bar was 12.4. Now we're going to do 95% confidence interval. 95% confidence interval is going to be using a z-score of 1.96. The sample standard deviation is 5.0, and like we said already, the mean is 12.4. So let's check our conditions first. N's got to be greater than or equal to 30. Well, my actual N is 50. Check. Good to go. My Z-score, as we already said, is 1.96. The margin of error, big E, is going to be my Z-score, 1.96, times my standard deviation divided by the square root of my number in the population on sample, that's 50. And that works out to be 1.39. That's my error, margin of error. Now, my actual interval, remember, is going to be my average plus or minus my error. So my average is 12.4, and I'm going to add and subtract 1.39. That's going to give me an interval of start small. That's going to give me an interval of 11.01 to 13.79. That's my interval. And that's with 95% confidence. I can guarantee you that it's going to fall within that range.